through projects. In this video, we will explain about the project, which is blockchain-based information sharing system. Introduction of the project. With the increasing volume and the sensitivity of the data in the digital age, there is a growing demand for secure and efficient method of information sharing. As our reliance on the digital platforms continues to expand, the sheer volume and the sensitivity of the data generated daily underscores the importance of robust systems for sharing the information. Whether it's personal data in healthcare, financial transactions, or the sensitive business information, the need for secure and efficient methods become paramount to safeguard against unauthorized access, data breaches, and ensuring the integrity of the shared information. Traditional centralized systems that are susceptible to a single point of failure, where any disruption or compromise to the central server or the authority can lead to system wide issues. In traditional centralized systems, the centralization of the data and the control in a single server or the authority presents a significant vulnerability. Any unexpected event, whether it be a technical glitch, a cyber attack, or a natural disaster affecting the central server, has a potential cripple to the entire system. This inherent fragility highlights the need for a more resilient and distributed approach to the information management. To mitigate the vulnerabilities associated with the centralized system, the project advocates for the adoption of the blockchain based information sharing system. This decentralized approach not only enhances security through cryptographic measures and consensus mechanisms, but also ensures transparency by distributing the shared ledger across a network of nodes. Blockchain technology is an advanced database mechanism that allows transparent information sharing. Blockchain database stores the data in blocks that are linked together in a chain. The data is chronologically consistent because we cannot delete or modify the chain without the consensus from the network. As a result, we can use blockchain technology to create an unalterable or immutable ledger for tracking orders, payments, accounts, and other transactions. The system has built-in mechanisms that prevent unauthorized transaction entries and create consistency in the shared view of these transactions. Various blockchain types like Ethereum, Bitcoin, Stellar, and Ripple exist, each with distinct features, governance models, and use cases. This project utilizes Ethereum, known for more than transaction recording. It supports smart contracts that autonomously manages tasks like data storage and retrieval without central authority. Ethereum strengths include app creation, an engaged developer community, security enhancements, and compatibility with the other blockchain projects. Objective of the project. The primary objective of the project is to strengthen the information security by implementing a blockchain based information sharing system. This involves leveraging cryptographic techniques and decentralized consensus mechanisms. One of the key objectives is to address the vulnerability of the traditional centralized system by adopting a decentralized approach. By distributing information across a network of nodes in a blockchain, the project seeks to eliminate single point of failure, ensuring systems resilience and continuity even in the face of disruptions. The project aims to empower users by providing them with greater control over their own data. Through the decentralized nature of the blockchain, participants retain ownership and decision making authority regarding the sharing and access permissions of their information, enhancing privacy and data autonomy. The overarching goal is to create an efficient and trustworthy platform for the information sharing by leveraging blockchain technology. The project seeks to streamline the process, reducing the likelihood of the errors and fostering a secure and collaborative environment for sharing the sensitive information across various domains. To implement this project, we need few requirements. And the software requirements are Python ideally of 3.7.0 version, Node.js, Visual Studio Community version, Ganache, MetaMask, which is a Chrome extension. Backend languages used are Python, JavaScript, Solidity. Hardware requirements are processor of i5 and above, RAM of 8 GB and above, and ROM of 20 GB and above. Front-end languages are HTML, CSS, JS. Bootstrap. Framework is Flask. To implement the project, we have designed various modules in the methodology. So the first module is user sign up. In this, we have sub-modules, which is sender. The sender module within the user sign up process refers to the individuals or the entities registering on the platform to share the information. The next one is receiver. In the context of user sign up, the receiver module pertains to users who register to receive the information. The next module is user login. In this module, we have sub-modules, which is adding the information. After successful login, the user can send the information. The next module is check the information. Here, the person can receive the information. Blockchain integration. Blockchain is integrated into the user sign-up and login process for secure and decentralized user authentication. This ensures that user identities are managed in tamper-resistant manner, reducing the risk of unauthorized access. The primary integration point in the core functionality of information sharing. Blockchain is employed to create a distributed ledger where shared information is recorded in a transparent, immutable, and secure manner. This enhances data integrity and ensures that the shared information remains unaltered. Blockchain can be integrated into the project to enable decentralized storage solutions, ensuring that users retain ownership of the data. This aligns with the goal of empowering users and enhancing data autonomy. The adoption of blockchain consensus mechanisms contribute to the elimination of single point of failure. Ganache. Ganache serves as a user-friendly interface facilitating Ethereum blockchain activities in the project. It presents critical details such as accounts, transactions, and smart contracts, offering a convenient platform for users to interact with the Ethereum blockchain. Ganache provides insights into individual blocks, offering crucial information like block numbers, timestamps, transactions, and gas usage. These insights aid in comprehensive blockchain analysis, enhancing the understanding of the system's performance and transaction dynamics within the project. Ganache is employed to access the data on local Ethereum blockchain within the project. It encompasses the information related to land record storage, system specifies, and user interactions, contributing to the overall functionality and data management of the project. MetaMask is integrated into the project as Ethereum wallet and browser extension. It enables users to manage cryptocurrencies and access decentralized applications seamlessly within the project's ecosystem. MetaMask is utilized in the project for secure Ethereum transactions. It ensures transparent ETH reduction and efficient transaction processing, enhancing the security and reliability of financial interactions within the project. To execute the project, first we need to open the code folder which contains source code files. This is the code folder of the project. This is the contracts folder. This folder consists of file related to Solidity code. It handles data structures, functions, and events with modifiers for validation. This is static folder, which contains files related to CSS, JavaScript, and Bootstrap. These files contribute to the visual and interactive aspects of the application. This is templates folder. Within this folder, we will find all the HTML pages used throughout the project. It includes pages like index.html, home.html, and more, representing various sections of the website. And here we have app.py file. This .py file contains the information related to front-end logic. It includes code written in Python that handles server-side operations such as processing user requests, interacting with the database, and generating dynamic content that to be rendered in HTML templates. Now we have to host the server. For that, I'm opening Ganache. Here we can see that server is hosted. Now we will get back to the code folder. This is the run.bat file. Instead of executing the project through command line interface, we have created this Windows bat file. Now we have to double click on this run.bat file to start the Flask server. Flask framework will host the application locally at the default address, which is the local host and port, unless configured differently. This is the local host and this 5000 is the port. Now we need to copy this local link provided by the framework and paste it in any web browser. So I'm copying the link. I prefer Google Chrome, so I'll paste it in that. Here we need to paste the link and then click on enter. This is the web page of the project, which is displaying in the browser, and this web page is built by using the Flask framework. Here we can see two links, which are user login and new user sign up. Prior to login, first we need to sign up as a user. For that, we need to click on new user sign up. Here we are going to sign up as two users. First, we will do the sign up of one user. So here, username is Ramesh. And here we need to provide the password, contact number, email address, and the address. Now we need to click on add user. So here we can see that sign up is completed and details are saved to blockchain. Now we will do the sign up of other user. So here username is Suresh. Here we need to provide the password, contact number of the user, email address, and the address. Now we need to click on add user. So here we can see that sign up process is completed and details are saved in the blockchain. Now we will see how the details are saved in the blockchain. For that, I'm opening Ganache. The data has been stored in all these blocks. For each block, we will have date and time when that particular block was stored. So I'm opening block number 14. Here we have block hash and transaction hash of block 14. So I'm clicking on transaction hash. Here we have sender address, to contract address, gas used, gas price, gas limit, and transaction data. This is for block number 14. Similarly, we will have for other blocks also. And we use all these blocks for retrieving the data. I'm getting back to the web application. Now we will see the fluctuations of the ETH price with each transaction. For that, we have to open the MetaMask, which is the Chrome extension. So I'm opening the MetaMask. Here we need to provide the password for opening the MetaMask. So I'm giving the password. Now we need to click on unlock. Here MetaMask has opened and here we can see that I have balance of rupees 99.971 ETH in my MetaMask wallet, which represents the deducted amount after recent transaction. In the context of blockchain, transactions refers to the actions or operations that are recorded on the blockchain ledger. Now we will get back to the web application. Now, users have to send the information and receive the information, which is they have to share the information. For that, we have to log in as a user. So click on user login. Here we need to provide the credentials of the users to log in. So here I'm choosing Ramesh who will send the information. Any user can either send the information or receive the information. So I'm choosing Ramesh. Here we need to give the username as Ramesh who will send the information. And here we need to give the password which we have given at the sign up process. And now click on login. So Ramesh has logged in successfully. Here we can see various links which are add information, check the information and log out. So we need to click on add information to send the information. Here we need to select from the drop down any user. So I'm selecting the Suresh whom I want to send the information. And now we need to click on choose file to upload the information. So I want to send this image. Now click on open. And now we need to click on add information. So here we can see that information is added successfully to the blockchain. And this information has been sent to the user who is Suresh. Now we will see how the data has been stored in the blockchain. So here we can see that the new block is created, which is block number 17. And in this block number 17, the data has been stored, which is the recent data. Now we will get back to the web application. And now we will log out and log in as Suresh and see whether information is received or not. Click on log out. Click on user login. Provide the credentials of Suresh, which are the username and the password. Click on login. So Suresh logged in successfully. Here we need to click on check information to see whether information is received or not. So here we can see that from the person Ramesh, there are 3 messages sent. Here we can see a download link in download the file column. So I'm clicking on download button to download the information. So here in the status bar, we can see that the information is being downloaded. So this is the information which has downloaded. Now Suresh will be sending the information to Ramesh. For that, click on user screen. Click on add information. And here we need to select the user. So I'm selecting the user as Ramesh. We can choose any user, but I'm choosing Ramesh. Click on choose file. I will select the other image now. So I'm choosing this information, which is image, and now click on open. And now we need to click on add information. So here we can see that information is added successfully to blockchain, and this information is sent to the user who is Ramesh. Now we will log out and log in as Ramesh. Click on log out, click on user login and provide the credentials of the Ramesh. And now click on login. So here we can see that Ramesh is logged in successfully. And now we need to click on check information to see whether information is received from Suresh or not. So here we can see that Suresh has sent one information, and here we can see a download button. We need to click on that to download the information. So here in the status bar, we can see that the information is downloaded. Now we will check the ETH price whether it is detected or not, because we have made recent transactions. So from the MetaMask, I'm opening. Here we can see that ETH balance remains unchanged after each block creation because the project actions don't involve significant ETH transfers. This is normal as not all operations lead to substantial balance. Now get back to the web application. Click on logout. In this way, using blockchain, information can be shared securely. Conclusion of the project. The project marks a significant leap in security by seamlessly integrating blockchain. User authentication is fortified against tampering, ensuring a robust defense against unauthorized access. As its core, the information sharing system now operates on blockchain, ensuring unparalleled data integrity and immutability. The distributed ledger guarantees the transparent and secure record keeping, instilling a high level of trust among users. Users are now at the help of the data thanks to the integration of blockchain for decentralized storage solutions. This shift empowers users, fostering a sense of autonomy and ownership over their shared information. The project embrace of blockchain consensus mechanisms eradicates the vulnerability of single point of failure. The system's distribution across a network of nodes establishes resilience, ensuring seamless functionality despite potential disruptions.
Thank you for watching video. For more projects please visit our website www.trueprojects.in. For updates on latest project videos, please visit True Projects YouTube channel and subscribe.